Okay, 8th graders, welcome to video notes number 1 for this year. I know this is a new thing for us, but we will be just fine. So I'm going to label my journal. If what I suggest that you do is put your name on it. That's the main thing you need to have. 8th grade in math. We're going to leave it in the classroom most of the time. So if you will open to the very first page, we're going to create our table of contents. So you will need one table of contents page. It says Unit 1 on it, and it should be in the folder with the station information. So first thing we're going to do is cut along the dotted lines. We want it to fit in our journal. Alright, so I'm going to cut this. And what you need to do is glue it to the first page of your journal, and we're going to put a little bit of tape behind it so it will so the Unit 1 tab will be reinforced a little bit. Okay. So it only takes a small amount of glue. And okay. So, table of contents, the first unit is going to be rational numbers. So, go ahead and write that on the top. And for topic 1, it is going to be the real number system. That's going to be on page 1 in your journal. Okay, so now that you've done that, you can turn that over. And you can actually have one more page to cut around. There's no dotted lines on this one, but we're going to cut around this so we can glue this in our journal also. So once you trim the edges where you can glue it in, go ahead and write page 1 on the back of the table of contents. We need to use both sides of our pages. So there's 1, and I'm going to glue this in. Okay. All right, so number 1. Natural numbers, counting numbers, and natural numbers are the same thing. So natural numbers are counting numbers. They are simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on. The numbers that you count. When we naturally count, we do not start with 0. Whole numbers are the numbers 0, 1, 2, 3, 4, and so on and so on. Whole numbers. Integers include all whole numbers and also include their opposites, which are the negative numbers. So that would be -3, -2, -1, 0, 1, 2, 3. Because this is a, in this situation, if you'll look at the Venn diagram and with the cup activity that we're going to do today, you'll understand this better, but the each one is going to be inclusive of the other. So a counting number, a rational number includes counting numbers. Integers include counting numbers and whole numbers. It's a progression as it goes up, and so those numbers are also included in each one of those categories. Okay, so next one is rational. Rational include all the whole numbers, integers, fractions, and decimals. Okay, a rational number means that when you change the fraction to a decimal, the decimal will end. So we need to put that the decimal ends. That means that, like for example, 1/2, when you divide that, you're going to get 0.5, and it's going to come out evenly. It can, it can be more than one decimal place. 1/4 is 0.25, but they both have an end. They're not going to keep continuing on and on and on. Irrational numbers, on the other hand, do not end. They cannot be written in the form of a fraction where a and b are both integers. The square roots and non-square results in an irrational number. Okay, so here we're going to look and we're going to choose the subset that best describes each number. So 15 is going to be a counting number or a natural number. 2.5 is a decimal that ends, so it will be a rational number. -12 is on the opposite side of the 0. This will be an integer. 3/4. When we divide 3/4, we're going to get 0.75, and it's going to stop. It will come out evenly. That's going to be a rational number. -1.4. That is, yes, it would be an integer, but it would also be a rational number. It is a decimal that ends. And 14.2%, if we change that to a decimal, it's 0.142. That is a decimal that ends. That would be a rational number. 0.412, just like we wrote here. Well, not just like, because the number is opposite, but this is also a decimal that ends, a rational number. Negative 91, that would be an integer. 4 2/3, when I divide 2 divided by 3, I'm going to get 6, 6, 6, repeating, and it's never going to end, but it can be written as a decimal. So it is also a rational number. Pi, on the other hand, when you divide it, you get 3.1415, and I cannot write this as a decimal, so this will be an example of an irrational number. Irrational number. 6 will be just a regular counting number. And 4.222 can also be written as a fraction, so that would be rational. Okay, thank you.